welcome back to my system design series, and today is the lecture number 20 of DDIA series. Today we are going to explore these topics. Whether you are preparing for a system design interview or just curious about how large scale applications work, this video is for you. So let's get started. Okay, first let's understand what do you mean by replication. Replication is simply about keeping copies of your data on multiple machines. Think about it like having several branches of your favorite coffee shop in all over your town. Each branch carrying the same menu, having the same coffee taste, ensuring that the price and quality of the coffee is also same. So why do we need replication? So here are the three reasons why we need replication. First is geographical proximity. Data is kept closer to users to reduce the latency. Now, what do you mean by latency? Latency is the time taken by the data from, like, suppose if the client has sent a request, then it will get the response, right? So this whole time is called the latency. Second is high availability. Here, even if the one node fails, for example, one of your favorite coffee shop gets closed, you can still buy the coffee from other branches, right? Similarly, even if one node fails, the other nodes are still working and serving to the customers. Third is scalability. Scalability means more number of machines, and more number of machines means more capacity to handle the read request. It is similar like suppose you went out on a coffee shop and giving party to your friend. For example, there would be 100 people. Just assume then all these 100 customers are getting the coffee served. Now let's look at one of the basic concept of replication. Here in the diagram you can see that the client is sending the request to the leader. The leader then updates its data and it passes to all of its followers. Each follower holds the same copy of the data. Just like the multiple coffee shops having the same menu, same coffee and same price. Now let's talk about the leader-based replication. Sometimes it is also called master-slave replication. In this model, one of the node is assigned as leader and all the writes and changes are going to happen through it. The followers then update their own data by copying the changes from the leader. Now imagine you are sitting in the classroom. There is one teacher who is writing on the board. Here the teacher is the leader and all the students who are copying the data from the blackboard are the followers. The teacher is the only one who is going to make the changes and all the followers are going to follow her. Here in this diagram you can clearly see the separation of the roles. Here, the leader is accepting all the write changes and then it broadcasts all the changes to all of its followers. This ensures that every replica have the same data. However, only the leader is accepting the writes from the client. Reads can happen from any replica. But since writes are centralized, it is very important that the leader is robust and reliable. Let's now consider the two ways of replication. First is synchronous and second is asynchronous replication. What do you mean by synchronous replication? Imagine that you are having a group chat and before moving towards the next conversation, everyone, each and every member should reply with OK or thumbs up before moving forward. Similarly, when the write happens, the leader waits for at least one follower to confirm the change before telling the client that the update was successful. This guarantees that at least one follower has the same data at the same time as of leader. Now, what do you mean by asynchronous replication? In this case, it is like sending an email. The leader sends out the update but doesn't wait for the reply. This means the client will get the response quickly, but there is a risk that some followers might fall behind because of the network delay. This sequence diagram shows the difference clearly. In this diagram, the client is requesting or passing the changes to the leader. Leader is passing it to all the followers and it waits for the acknowledgement from one of the followers before passing the message to the client that all the changes are successful, which ensures the strong consistency for that replica. But below that, the asynchronous follower receives the update later. So there might be a small delay before all the followers' data is up to date. Now, if the requests are increased, then the capacity increases. And now if some of the nodes fail, then you have to replace that node, right? So every now and then, you need to add a new follower to your system. But how do you ensure that the new follower have the accurate copy of the data? To explain that, imagine that the new joinee have joined the organization in any of the new project. Instead of them to guess like what has happened so far, you give them the complete briefing, which is called a snapshot in this particular topic, and then update them with all the new developments after they have joined, which is called the replication log. So here is the step-by-step process. First, take the snapshot. That is to capture the consistent copy of the data at a moment in time. This is like taking the complete photo of the current state. Second is copy the snapshot. Now you need to send this snapshot to the new joinee or the new follower. Third is catch up with leader. The new follower then requests all the changes after the snapshot has been taken. Once it processes these changes, it is fully synchronized and can start serving the request. So in this diagram, you can see all the steps are been mentioned. Now, why is understanding the replication is so important in system design interviews? Many large-scale systems, from social media platform to online retail websites, rely on application to ensure the high availability, low latency, and fault tolerance. Interviewers often ask that how to design the systems that remains available even if some of the nodes are getting failed, trade-off between consistency and latency, the difference between various replication strategies, for example, leader-based, multiple leader, or leaderless replication. For example, you might be asked to design that highly available database for a global application. Your answer should mention how you would replicate the data across several regions, the choice between synchronous and asynchronous replication, and the strategies to handle the leader failure. Understanding this trade-off and explaining to the interviewer clearly is a major plus in system design rounds. Let's wrap up this video today with a story. Imagine a small startup that began with a single server. For example, there is one small coffee shop. As the company grew, all the customers from different world or maybe different countries started coming up. To serve them better, the engineers introduced the replication. You know, when some people says that there is a main office situated in Hyderabad, in whole India, other are the small offices. Similarly, this is the concept. Some branches have to wait for the latest update, which is called the synchronous replication, while others got the update a bit later, which is called asynchronous replication. When the new branches open, it will get the full briefing of the current state. And then the team will ensure that it will get all the updates after that. This story depicts the evolution of many modern systems. It shows replication not only improves the performance and reliability, but also how careful design choices can address real-world challenges. When you discuss this concept in the interview, you are not just showing the theory concepts, but also demonstrating that how you would apply this concept to build robust, scalable systems. I hope you have liked this video. Don't forget to watch the previous videos. It will make your concepts very strong. And if you find this video helpful, please make sure to subscribe, like, and comment if you have any doubts. Thank you so much for watching.